All right, this video is for use after doing pages, I want to say 33 and 35 in your booklet. So I learned a lot from you guys working on those two pages, and then another packet that's called Making Graphs of Things. Some of you worked on this packet yesterday. So let's go through this Making Graphs of Things kind of cheat sheet. So things that we can make graphs of. So you might be asked to make a graph of a linear function. That's just a straight line. Your quadratic function is in the form of usually some sort of f of x equals ax squared plus bx plus c, and it makes this really nice graph called a parabola. Okay. Linear functions are usually in the form of y equals mx plus b, but not always. So quadratic functions turn out to be a parabola. It can open up or it can open down. And then some questions they might ask afterwards, so follow-up questions. They might ask for the vertex, which is that turning point. It's a coordinate pair, or the axis of symmetry, and we'll go through that in detail. It's a vertical line, and it's x equals some number. All right, some constant. Okay. Well, there are square root functions. I haven't seen one of these yet on the new exam, but these have been on previous exams, and they do this weird curve. They also have a place where there's no graph at all. So we'll see that in more detail. Absolute value function looks like a V, and that's like this kind of thing. So there's the absolute value symbols and then an X or more inside. This one happens to have what's called a restricted domain. So they ask them to start at, it looks like maybe -4 and don't go any farther than +4. So a restricted domain, that information is given to you like this, -4 over the interval, like that. So we'll talk a little bit about that. We have an example. You could be asked to graph a system of equations, which just means you're graphing more than one equation. This one happens to be both linears, two linear equations, but you could also have a quadratic linear system, and then we have points of intersection. So they might be asking you for the solutions, which are those pairs or points of intersection with both x and y, but sometimes they only want the x values. So they'll say, what are the values of x when the two functions are equal to each other? So for example, the quadratic is f of x and the line is g of x. And so there you're just giving a list of the x values. You might be asked to graph a single inequality, but typically you're asked to draw two inequalities. Now, the shading on this one's a little bit wild, but at any rate, this one has a solid border line and shading above. Then it has a dotted border line and shading below, which then means this area over here where I have both the blue and the red shading is my solution set. And they're going to ask usually a follow-up question about a point in the solution set. Is this point in the solution set? Is it not? If you're on a dotted line, that is no go, not in the solution set if you're on a dotted line. So solid lines are in the solution set, and you just need to make sure you're in both solutions. Okay, so now we're going to go through a couple questions in the packet. Really great questions today. So the first one is on the front page of the packet. So I'm just going to pull the packet up real quick, and this is what it looks like. It says, on the set of axes below, draw the graph of y equals x squared minus 4x minus 1. Hopefully when you see that x squared, you know it's going to be a quadratic, which means your answer is going to be some sort of parabola. These questions almost always end with some sort of follow-up. This one says, What's the equation of the axis of symmetry? It also could be asking for the max or the min. And both of those are considered to be turning points or the vertex. So this is also just a 2-point question. So I don't know if they take it holistically. I think they do. So if you make small errors in both locations, you still might get 1 point. But the goal is to get 2 points because it's not a difficult question. So what you're going to do is you have this piece of paper which has a lot of screen captures from Desmos. And I'm going to annotate this as well as kind of demo some of the things that I did in Desmos to get this. So the first thing I should probably do is tell you that I entered the quadratic equation in Desmos. Now, it might start off with a y equals, or it might start off with an f of x equals. So f of x is function notation. Both of these allow a table to be created. So the first mistake I saw, the first maybe improvement we can make, there's putting this in and then being like, oh, I need some graphs, some points. Well, you want to make sure you graph all the points that are easy to understand. So someone clicked on the x-intercept, and that's great, but you would never tell somebody, hey man, can you go plot negative 0.23607, 0? No, but you might tell them to go graph this point, which is 2, negative 5. So something that I call a friendly point has no decimal places or maybe only one decimal place. So when you're putting your equation in and the graph pops up, there's a couple things that we're going to do. So the first thing we're going to focus on is getting a table. So this is the settings wheel, and when you press the settings wheel, this menu comes up with the words delete all and done and this, which says create a table. And when you tap on that, you will automatically get a table that is from -2 to +2. Now that may or may not be helpful to you. In this scenario, the -2 does not help us because our graph paper does not go up to +11. However, that does mean that this -1, 4 is the first good point that I can plot. But as you're looking through this, I have 4, -1, -4, -5, and nothing else. So you want to keep adding points into your table. And I kept going till I got back to the number 11. So I extended and I put in 3, 4, 5, and 6. And there's a couple things that pop up that are really valuable here. As I put these points in my table, they do show up on the graph that is displayed next to it. So here are all these beautiful points that are now on my graph that are easy to plot. And I'm going to talk about my graph in a second because I did make an adjustment. The next thing to say, something that's really important about quadratics, is there's symmetry. So notice that 2, -5 is alone. This is going to be the minimum. And then we have symmetry as we move out from that. And what that means is that we will have points on the same horizontal as we graph things. So notice that they are across from each other. Couple more things. Because there is this symmetry, I can also, and I'm going to use a actual line, I can draw a line on my paper that is the mirror image, the fold line or the axis of symmetry. Okay. Now, there's a few more things I need to talk about because I did make some leaps because I'm on paper right now, not physically in Desmos. There's two things I want to talk about. The first one is up here with the plus-minus symbol, okay? So let me switch over to Desmos and take us through some of this again. All right, so here is my function, and you can see what's on the graph. And I'm going to tell you right now, even though, and I'm using my cursor here, let me just get that. Yeah, even though this point is here, great, and this point is here, they be ugly. I do have this point fabulous and that point fabulous, but 2 points is not enough. So here we go. Settings wheel, table, and then remember I talked about extending the table. You could just go 3, enter, 4, enter, 5, enter, 6, and then I'm done. There it is. So I've extended my table. I have everything I need. Now, this is the next part that I want to talk about. Right here, you can see that we have -2, -4, -6. Like, this isn't friendly for us. So if I zoom out 1, so this is really important for my friends that don't have touch screen, or if you just want to have it be really nice and zoom out exactly as you need it. As soon as you hit zoom out, it goes to a scale that is 0 to 5. Each line is a value of 1, which means now I can plot up 4, down 1, down 4, down 5, down 4, down 1, up 4, and I am done making my graph on paper. I will put a paper, or I'll put an answer key in Google Classroom, so those of you that want to see it hand drawn, you can. Okay, so let's see if there's anything else. So we talked about backing out to get a nice grid. Last year I told the students to give me 5. All right, cheat sheet. So there's that. And then the key features. Once again, they're going to ask us about that. Let me go back to this axis of symmetry and the vertex. So for this particular picture, the vertex, the turning point, is a minimum. And it's the coordinate pair 2, 5. Well, if you go to the x-axis, which is this axis right here, this is the value 2, 0. And any point that's along this line will have an x value of 2. So the answer for what is the axis of symmetry, it's the line x equals 2. That's the equation of that line. And if I want to, I can go to Desmos. So let me go back here, and I'm just going to go to this next line right here and type in x equals 2. And there you go. I now have a vertical line that cuts my parabola in half. And I can confirm that I have the right answer. Yay! All right, so there's that question. All right, let's move on to another question in the packet and another page of our cheat sheet. All right, so if you turn the page in the cheat sheet, this is the one that had a restricted domain. So when they tell you to restrict your domain, first of all, they tell you it's the x variable that they want you to restrict. And really what that means you're doing, and I'm hoping I can actually make this work on the paper here. I'm going to use some boxes. It means that if they want you to start your graph at -2, I'm going to go here like this, and I want to be able to select that guy. There we go, and I want to make it solid. So there will be no graph over there, and I'm going to make another rectangle all the way over to 7. Okay, so that means right here. And I'm going to fill that one. Oh, maybe it'll let me fill it just like that. Fill. Oh, it didn't do it. So sorry. Let me just click on that and fill it. There we go. Fill only. There we go. All right. So restricted domain means I'm only going from -2 to +7. That's where the graph begins. That's where it ends. Done. Okay, let's go to our cheat sheet. Okay, so here's the second page of the cheat sheet. First thing I did was I put my equation into Desmos. Just so you're aware, this is where the radical symbol is. There are more symbols when there's like a second page of symbols, and then of course there's our alphabet. This is the absolute value symbol. And then up here is how you can get quadratic. You can also go shift caret, or which is shift number 6. We did have that restricted domain. So when I go and put it in and then look at my table turns out to be this first table right here. And yep, this is a great point. I love that one. This one is great. This is garbage. I don't want to try to graph that. This is garbage. I don't want to graph that. And so as I continue to put in more and more values, I'm getting more and more garbage. And in essence, if I delete those out of my table, I'm going to actually see just the points I want to graph on my graph, or I can just focus on the table to help me graph those points. So notice that I'm starting at -2 in the x's and I'm stopping at 7. My picture is not restricted, but I'm going to need to remember to slow down and not graph past the number 7. So that's going to be filled in or invisible. I should put maybe white over here. So I can change that to fill and then it's gone. And then let's see, what else did I want to say? I can show you briefly how I did that with the table. So let me go here. There's my function. And so once again, ugly the way it looks right now. So two different things I want to do. F of x will allow me to get a table. I don't like this. So that, once again, this is how I can do and these things, get rid of things. I can just delete. Here we go. Delete, and it says undefined, and I can go back here and say delete undefined, but now I can do, hey, I want 2, that's great. Do I want 3? No, I'm going to delete that one out. You can do whatever you want, and I'm going to put 7 in here. So there's the 4 points I want, and then really what I need to do, I'm just going to shrink that out, is I want to back this out once, zoom out, boink, and now I can see the graph the way I want it, and I can always click on these points to get their coordinate pairs, and I'm going to end at 7, 3. Okay. All right. I think in the cheat sheet I put also, there it is. I did the very last page is page 6 in the packet, question number 25. And the reason why I brought this one in was that our tables naturally start at -2. And the problem is this graph started at -3, 0. So please make sure you're considering what else is going on. Now, this one did not have a restricted domain. So that means when you graph it, you either can put a point there and then go ahead, but then you're going off the graph, or you're putting an arrowhead in there because the domain is not restricted. In this other graph, you are starting here and you are ending here, and there's no additional graph on either side. One of the reasons why the graph of a radical or a square root is a hot disaster is you can't have a negative number under that radical. It won't be a real value, a real number value. Okay, so I think there's one more page to do in the cheat sheet. There's a lot going on in this one. Okay, so this is page 3. Question 35. So I'm going to go to page 3. Now, let me talk about this. I'm so sorry. The graph that you received did not have an X or a Y axis on it. So if it's not there, take a moment to draw it in. Okay. It says solve the following system of inequalities graphically on the grid below. Label the solution S. So watch out for that instruction. Sometimes it's listed within the prompt, sometimes it's listed separately. So the problem with these two things, even if I were to switch these to equal signs, since it's not y equals, it's not going to give me a table. But I have a couple interesting ways for us to get around that if it's hard to find what we call friendly points. So let me go ahead and go to the cheat sheet first. First of all, I can put everything in, and then I also put in the point, which is part of the question down here at the bottom. Is the point 3, 7 in the solution set? Explain your answer. So I did that so I could see that that point is on a dotted line. Your inequality symbols, are in here as well. So you can see your less than on greater than, your less than or equal to, greater than or equal to. So you don't have to look too far, except you do need to open up the keyboard. You can see that I zoomed out. And then, like I said, the problem is there's not a lot of friendly points. So I think some people saw this one right here and some people saw that one right there. And then you started to get jammed up. So let me show you a couple different tricks in Desmos to help with that process. When I go here to the inequality, and it's different colors, but just bear with me. So first thing I can do is I am going to zoom out first just to get a general image of what's going on. Okay, I've got this intersection point, which is close to -1 and 5.7. Okay, great. I have this point. That's good. It's possible, let me go up to here. Yeah. So when you click in here, notice that it gave me the y-intercept. Now it did give me a decent x-intercept, but it's not super fabulous. It's 6 2/3. So I want to talk about how you can zoom in and see things, because if you don't want to rearrange the equations and you can't make a table, what can you do? So a couple things. I'm going to turn this other graph off so I can see one thing at a time. So you can always have things in and turn them off and turn them on, turn them on, turn them off. Okay, I'm going back to this one. Now I just did zoom out, but now I'm going to zoom in, and I'm really looking for at least some more points right in this area. So if I zoom in and zoom in again, like, ooh, so this is kind of interesting. I have, and it kind of looks crazy when I move things around, I have a 1, 2, 3, 4, 5 axis, and that's great, but there's all these extra lines. And this happens when I do other things as well. Well, this wrench might be a little cuckoo crazy. And if things go nuts, I believe if you hit the home key, it takes you right back to where we started. So even here, if I go into the wrench, there is these things called axis numbers, and there's also minor grid lines. So watch what happens when I click minor grid lines. All the gray goes away, but now I really only have 0, 2, 4. I don't know if I like that, but watch what happens as I zoom out. So I'm going to zoom out. Oh, now that's even worse because I just have that. But when I zoom out again, oh, zooming in maybe. Hey, there she is. I zoomed in. So now I'm going to go here and I can see the point 0, 5. And then it's not going to let you put a point there, but now can you really see that? Oh, there it is, 4, 2. So what I'm doing is I'm holding down my cursor and moving it around, and I can land right on 4, 2. So if you can confirm 2 points to draw that straight line, you're going to be a much happier camper. And please, please, please use that straight edge. So this slope happens to be down 3/4. That's why that occurs. Okay, so let's do the same thing with the other one. And notice how, like, I'm just going to go back. I'm going to hit home. I can put back on my grid lines for all of them, but then I can like zoom out. Oh, maybe I want to zoom in, and of course I want to turn something on. Oh, where'd it go? There she is. So I just need a couple points, and actually this one might be nice. So let's look. Let's go back and turn off our minor grid lines, and I might need to just close that. So 3, 7 looks like it is a nice point. There it is, 3, 7. Once again, I can go, and I know it's hard because you don't have a mouse, but you guys have really adapted quite nicely. Here's another friendly point. So finding 2 or 3 coordinate pairs that are integers will help you make a nice graph. Okay, so then let's just double check what else is in this. So you can make your dotted lines. So there we go. Dotted lines are for no equal sign, solid line for equal sign. You can have 2 solid, you can have 2 dotted, you could have 1 of each. This right here is just kind of showing the difference between minor grid lines and removing the minor grid lines to remind you that that's an option. Remember, you're trying to squeeze all the points, so making really gorgeous graphs is a great way to get easy points on this exam. All right, so hopefully this helped, and we'll practice some more tomorrow.